Okay, so today we are starting a new chapter. It's on solving trig equations. So you need to remember how to solve equations, and then we have to do some QRSing. So we're going to combine the two. So let's get started. First of all, I need you to remember that when you're taking the sine, cosine, and tan of angles, we've got our little ASTC chart. Remember that if you take the cosine of 30, you get radical 3 over 2. If you take the cosine of 330, you also get radical 3 over 2. So there are 2 degree values that if you take the cosine of them, that both equal radical 3 over 2. So we're going to be getting some more than one answer for our equations. Okay? Why are they positive? Because cosine's positive in 1 and 4. The cosine of 210 and the cosine of 150, also with reference angles of 30, would give you negative radical 3 over 2. So let's take a look at the first one. So the first one is exactly what I just did. To solve this, I'm going to say, okay, what quadrant am I in? What's my reference angle? I don't really need the sign, but since I use it for other problems, I'll use it here as well. I should be looking to get the quadrant at whether the radical is positive or negative. Okay? So look at radical 3 over 2. It is positive. Where is cosine positive? That's what you should be doing for the quadrant. So cosine's positive in quadrants 1 and 4. To get the reference angle, you can do second cosine radical 3 over 2, but you should, from your chart, know that the cosine of 30 is radical 3 over 2. And this is just a reminder for the signs that we're positive. So I'm going to say that theta can be 30 degrees and 360 minus 30 degrees, or 330 degrees. And we know that that's true. You could check it out on your calculator and it would give you the same exact decimal. That's 0.866. All right, now if I say sine theta equals negative radical 3 over 2, so again I'm looking at the quadrant, reference angle, sine. So I'm looking at the negative. To get that quadrant, I look at the negative. Okay? So where is sine negative? That's what I'm asking myself to get the quadrant. And it is negative in quadrants 3 and 4. To find the reference angle, I'm going to do second sine positive radical 3 over 2. And that, or we could just know from our chart that the sine of 60 is radical 3 over 2. And we're just double checking that those are both negative. So now in quadrant 3, I am looking for, again, this angle. This is what I'm looking for, but I know this piece here is 60. And in quadrant 4, I'm looking for this angle theta. And I know that this piece is 60. So in quadrant 3, to find theta, so the measure of angle theta would be 210 minus 180 for quadrant 3. Oh, I'm sorry. Yeah, 210 minus 60. Geez, what am I thinking there? Sorry about that. Hold on. Another mistake. Sorry. All right. Restart. In quadrant 3, I am looking for that full angle. I know it's 60 plus 180. So, there we go. The measure of that angle is 240. Whew, sorry about that. And in quadrant 4, I'm looking for the big angle in quadrant 4, so I'm going to do 360 minus 60, and that's 300. So if you check on the calculator, the sine of 240 and the sine of 300, they yield the same exact decimal. Okay, next one. Tan theta equals -1. So QRS. So to get that quadrant, I'm looking at that negative sign, and I'm saying, where is tan negative? Where is tan negative? Tan is negative in quadrants 2 and 4. Now the reference angle I know is 45, but you can also do second tan of 1. And that will give you 45. And again, this is just emphasizing that I've got the quadrants where tan is negative for the sine. So I need angles in quadrant 2 and 4 now. So again, I am looking for this angle right there. I know the reference angle is 45. We have already done these similarly in a previous chapter, so this should be review. I am now looking for the angle in quadrant 4, and I know this angle is 45. So to find the answer in quadrant 2, so the measure of angle theta is equal to 180 minus 45, which is 135. And in quadrant 4, I'm doing 360 minus 45, which is 315 degrees. So those are the answers for number 3. Now on number 4 and 5, if it says 0, 1, or -1 for cosine or sine, those are not quadrantal. Those are not in a quadrant. They are quadrantal angles, which means that you can only have answers of 90, 180, 270. So if you look at the unit circle, and you take your point here at 1, 0, which is 0 degrees, and then we have 0, 1, which is 90, and -1, 0, which is 180, and 270, we are at 0, -1. I'm looking for where the x-coordinate is 0. So right here and right here, okay? So the cosine of 90 degrees equals 0, and the cosine of 270 degrees equals 0. So you can use your calculator to get one of them. If you go to second cosine of 0, it will tell you the 90-degree one. It will not, however, tell you the 270. So you need to go around the unit circle and find them. So if you're not sure, you could set up the drawing, or you could just go around and test them out. The cosine of 180 on your calculator will say -1. The cosine of 270 we already did. Those are the answers. The cosine of 0 is going to say +1. So cos 180, okay, and cos 0, +1, okay? So the answer for theta, the measure of angle theta, is 90 and 270. because those are the ones when you plug them in for theta that you got 0. So can you use QRS? No. Same thing with sine theta equals -1. No. If you look at the unit circle, again, we're looking for where y coordinates are -1. So I believe down here we have a y coordinate of -1 at 270. Up here our coordinate is 0, 1, and that's 90. And the other two, they're both 0. So the only one that's going to work for this one is the sine of 270 is equal to -1. If you check the sine of 0, you get 0. If you check the sine of 90, you get +1. And if you check the sine of 180, you get 0 again. The only one that worked was 270. So this one has only one answer. So the measure of angle theta, forgot the angle symbol on the last one, go back and put that in, is equal to 270. So if you go to your calculator, it would say the same thing. You cannot do QRS on quadrantals. Okay, now, if we want to take and expand this into solving equations, let's first answer this question. How many answers do most of the above trig equations have? They have 2. Sometimes there could be up to 4 answers, though. So there could be 1, like there was on number 5, but there can also be 2. There can be no solution. There can be more than 4, but you will not be exposed to any of those. All right, so let's say we're asked to solve this equation. You can pretend that it just says 4 equals 7 minus 6x. So if you were to solve that, you would subtract 7 and get -3 equals -6x and divide by -6. So you get 1/2 equals x. Okay? Then you would want to put the cosine back in and say cosine x. And maybe you want to say equals 1/2 on this side. Okay? If you're going to do it keeping the cosine, it's the same exact procedure. So you'd get -3 equals -6 cosine x, and you divide by -6. So you get cosine x equals 1/2. You can write it like that. So now you're back to where you were in the problems up above for 1, 2, and 3. So what quadrant? See, this is positive. So what quadrants is cosine positive in? So where is cosine positive? That is what you are finding out when you are writing down your quadrants. So it is positive in 1 and 4. The reference angle you should know is 60. You can do second cos 1 divided by 2, but it's 60. The sign just reinforces that. So now, angle x, the measure of angle x, is equal to 60 degrees for quadrant 1 and 360 minus 60, which is 300 for quadrant 4. And those are your answers. Okay, next page. You can check this now using the calculator, okay? So think about this a little bit. I think that we would want to put in 0 to 360 because that's what we were asked. Well, that's what you're going to be asked to solve them, is between 0 and 360. And then for the y max, your max is going to be 13. Take that vertical shift plus the amplitude, and you get 13. So I'm going to make the y max at least 13. You could make it 13 or 14. So I'm going to go here. I'm going to put my mode in degree mode, and I'm there. I plug it into my calculator as y1 equals 4. That's the left side of the equation. And the right side, I'm going to put 7 minus 6 cos x. You should be doing this along with me. And then I'm going to go into that window And I'm going to go 0 to 360 for x min and x max. I always make my x scale 30 or 90 if I'm in degree mode, and we talked about changing that y max to 13 or 14. And then I should be able to hit graph. So that one should be horizontal line, and there we go. So I'm looking for those intersections. So this is a good check. So I can do second, trace, 5, intersect, enter, enter, enter. And there's the first one, 60 degrees. That's what we got. Second, trace, intersect again. And I'm going to move along that line because I think that'll get me there. I just need to get close to the intersection. There. It's still going. Enter, enter, enter. And you should see the 300. Okay, so we got the measure of angle x to be 60 and 300, which is what we got when we did it algebraically. All right, so you need to solve these algebraically, though, because that's what you would be doing and be asked to do if you were when you're taking your final. So let's take a look at number 7. I'm going to subtract 8 from both sides, and I get negative 5 equals negative 6 sine x, and then I'm going to divide both sides by negative 6. So I really get sine x equals positive 5 over 6. Now this one I don't have like 30 or 45 or 60, so I'm going to have to use my calculator. But first I'm going to set up QRS. So to get that quadrant again, I'm looking, where is sine positive? Okay? Because that's 5/6 is positive. So it's positive in quadrants 1 and 2. To find the reference angle, I have no choice but to do second sine 5 divided by 6 on my calculator, and this is just plus plus. So I have to find that, so I'm going to go to my home screen and do second sine 5 divided by 6. So I get 56.44 degrees. Now if you look here, it says to the nearest hundredth of a degree. So in quadrant 1, the measure of angle x is 56.44 degrees. And in quadrant 2, I'm going to do 180 minus 56.44, which on the calculator, I'm going to do 180 minus second ants. And I get 123.557, which is 0.56. And that is how I would solve that one. And again, you could check in the calculator to see if it's correct. Now the next one says find all possible solutions in radians. So I'm going to go to radian mode. So first let's solve it. So I'm going to get 4 tan theta minus 12 equals 6 minus tan theta. Then I'm going to add tan theta to both sides, just like it's an x, and I'm going to add 12 to both sides. So I get 5 tan theta equals 18, and then divide by 5. So tan theta is equal to 18 over 5, and I'm just going to leave it like that. So now I'm going to do QRS. So 18 over 5 is positive. Where is tan positive? Quadrants 1 and 3. To get that reference angle, I'm going to do second tan 18 divided by 5. Now, I have to check my mode. I'm not in radians, so I'm going to do that first. Then I'm going to do second tan 18 divided by 5. And I get a reference angle of 1.2 now. Now remember, 1 radian is about 57 degrees, so we're probably around 60-some degrees. So my reference angle was 1.2998, and that's radians, and my tan was positive. So in quadrant 1, the measure of angle theta is to the nearest hundredth 1.30. The 9 rounds the 9 up to a 0, which rounds the 2 up to a 3. In quadrant 3, I am doing 180, supposed to be doing 180 plus the reference angle. Okay, but, so again, a little picture here, over here, this is what we're looking for, theta. We know this piece is 1.29. So we're in radians, so that's pi. So I'm going to take and do pi plus that reference angle, which is the 1.2998. So I'm going to, in my calculator, do ants plus pi. Okay? So let's go do that. So I have that, so I'm just going to hit plus. It's going to say ants plus, and then I want to add 180, but in radians. So 4.44. So that is the answer, and that's radians, to the measure of angle theta there. Last one, and this cosecant. So let's solve it like usual. I'm going to put myself back in degrees eventually. So 3 cosecant theta minus 4 equals 6 cosecant theta plus 2. Distribute. I'm going to subtract 6 cosecant theta from both sides and add 4 to both sides. When I do that, those cancel. I get negative 3 cosecant theta equals 6, and then I'm going to divide by negative 3. So I get cosecant theta equals negative 2. So if cosecant theta equals negative 2 over 1, then you should be thinking sine theta equals the reciprocal of that, which is negative 1 over 2. And then we QRS that. So QRS, I'm thinking where is sine negative, and that's in quadrants 3 and 4. The reference angle I know is 30. I don't need my calculator, and those are both negative. So I'm looking for the measure of angle theta in quadrant 3. That is 180 plus 30, which is 210. And in quadrant 4, 360 minus 30, which is 330. So those are my 2 answers to the nearest degree. Remember, your calculator's in radian mode. You might want to change it to degree. And that is it. Have a good night.